useEffect is one of the most widely used React hooks in a React functional component, but majority of developers are at times confused with the usage of this hook. In this video, we are going to cover everything about this hook in depth. We'll look into several examples covering all the use cases and how to efficiently use this hook to make our code more performant. Also, do not miss some of the tips and tricks at the end of this video that can help you write and structure your code even better. So now, let's get started. So in simple terms, use effects are used to perform side effects from a functional component and used as an alternative to some of the React lifecycle methods which are available in React class-based components. So in the code, as you can see, here is the basic skeleton of a use effect hook in a functional component. So there are two arguments. Here's the first one, which is the callback function in which we write our side effect, and a cleanup function. The second one is the dependency array, which is an optional parameter, but depending upon how we pass the dependency array, we'll cover a couple of scenarios with examples and take a look how is this block behaving. So in order to demonstrate all the cases, we have a very simple code snippet here with an hypothetical boolean state called is logged in and a button basically to toggle the state to either true or false, like this. So let us see the first case where we do not pass anything as a second argument. So no dependency array and simple use effect, like this. So as we know, use effect runs every time the state or the prop for a particular component changes. So now we'll try to simulate this by changing this is logged in state by clicking on this button. So as you can see here, if I click on this login button, we are basically setting the state to true, and since the state is again changed, this use effect is running and we are seeing this being logged in our console. Now again, if I click on this button, now we are setting the state back to false and this is being logged again in the console. So if I go ahead, click this multiple times, you can see the same number of times we are getting this getting logged. So from the case one, what we observed is if we do not pass any dependency array as a second argument to this use effect hook, whatever the effect we write inside it, inside this callback function, is going to run exactly the same number of times the prop and the state of this functional component changes. So now let us cover the case 2 where we are passing an empty dependency array as a second argument to this use effect hook. Now if I go ahead and reload this page, you can see we are getting a log of this statement in the console. Now if you go ahead and click on this button as many times as you want, and we know we are changing the state as we do this, but we do not see any repeated logs in the console. Now what do we observe is if we pass an empty array as a second argument, it behaves similar to component did mount, the lifecycle method which we see in class-based component. So whenever you want to do anything on mount of a particular component and you just want it to run just once, you can use a use effect with an empty dependency array. So one thing you might observe is like we are getting this logged twice in the console. Now why is this happening? So with React 18, React intentionally mounts our component twice to help us find bugs and make sure that the cleanup or the unmount functions, which we'll be talking soon in this video, are running well. This only happens in strict and development mode. So in a production build, effects will only be called once when their dependency array changes. So you did not to worry about this. And also I'll be leaving a detailed link on this from the React official team describing why this was done. So for the case 3, we have changed our example a little. So now we have two states, one for the color, one for the text, and if we scroll down, we have an option to select different color. So if we select a color, it is going to set the state for this color, whatever the color we have selected, and then this is going to be seen on this text. So whatever the color is selected in the particular state, we are going to use this as the text color for this h1 tag. Now what we want is whenever we change this color, right, whenever we select a color, what do we want is we want the color to be read as in this text. So here what we are doing is we are passing this color state as a dependency array to this use effect, and now whenever this color changes, it is going to set the text and it will read as selected color is the whatever the color value we have selected from the drop down. So now let's see this in action. So since the color is selected as a blue by default, as you can see here, so we see a text which reads selected color is blue, and also the text color here is blue. If I go ahead, select a different color, for an example red, this is going to change it to red, and also the background color of the text is going to change to red. So whenever you have a case where you want to change something based on a prop or a state value, then you can pass that prop or state value as a dependency array to the effect and do whatever you want within this effect based on that change. Now this is similar to the component did update lifecycle method which we used to see in the class-based component. Now next we are going to cover the cleanup and the unmount function which we talked earlier. So this is similar to the component will unmount lifecycle method which we used to find in the class-based components. Now here to depict this, we have a simple text state which has a default value which reads this text will change in 5 seconds, and then we are just showing this text in this p tag obviously. Now what we want to do is we want to set a timeout for 5 seconds, and after the 5 seconds we are going to change the state of this text to text has been changed, and this is how we can do it. So if I come ahead and reload this page, we can see that we get this default text, and after the 5 seconds this is going to change to text has been changed. Now this is absolutely fine, the things are working fine, but one thing you should do is you should always clear your set timeout when this component unmounts. So here I'm going to create a constant called timer and assign it to this send timeout. Next, what I'm going to do is I'm going to clear this timer whenever our component unmounts. So for this, we have a return function or a return statement from this effect function, effect callback obviously, where we can perform certain things like cleanup and unsubscribing from any events. So here, what I'm checking is if there is a timer, we are going to clear this. So this is a performance optimization. So there is no memory leaks, no timer gets running in the background. This is always a good practice to clean up the browser APIs like set timeouts or promises or any subscription based things. So now if we rerun this thing again, we won't see any changes visually, but again under the hood the performance is definitely optimized. Now let me reload this, we'll get this default text, and after the 5 seconds the text will change to the text has been changed like this. So always remember to clean up your effects when the component unmounts. Now next, I'm going to cover an edge case scenario which is very common amongst the new developers or the ones who are new to React and its concepts. This is called infinite loop problem in useEffect. To understand this, we have a very simple example here. So we have a functional component with two states, one with value and a count, and here we have an input field where we are changing this value state on each keystroke. Again, we have a useEffect which is only incrementing this count and setting the state accordingly, and then we can also see that we don't have any dependency array. So what do you think if I go ahead and save this code and run this? What is going to happen? And try to pause for a second, try to remember whatever we have covered till now in this video, and try to solve like what is going to happen and try to come up with a solution which can solve this. So I can pause here for 2 seconds and then I'll run this code. So okay, now I'm going to save this and run this code. Whoa, now we see this count is getting incremented indefinitely, and this is the infinite loop problem. So let us understand why is this happening. So as you can see, we have a useEffect which do not have any dependency array. So as we discussed, this is going to run each time, every time this app component re-renders. Now why is this app component re-rendering? Let's see in the useEffect what we are doing is we are setting the count. So we are setting a state which we know re-renders a component. So whenever this useEffect runs, it is setting the state which again is re-rendering the component, and this is going into the loop indefinitely. That's why we are seeing this count getting incremented again and again and again, and it will go on unless it blocks your main JavaScript thread, and ultimately it will make your application go freezed. So in order to solve this, what we are going to do is we are going to pass a dependency array, and we want this count to get incremented only and only if the value changes. So I'm going to pass a value to this array and then save it, and I'll try to reload it. Now if I enter key, so we have 4 letters here and the count is also 4. So this is what we are expecting to it. So always remember to check your dependency array for any effect and make sure you don't fall into this infinite loop. Another problem which we generally face is while dealing with objects and function in the dependency array. So if we take into an account the basics of JavaScript, we know that two functions or object types with same value and body are not considered same, as they refer to different locations in the memory. These are also known as JavaScript non-primitive types. And additionally, useEffect also does a shallow comparison of dependencies to verify if they have been updated or not. So due to this, the object and the functions are always different for React when it is compared, and this in return forces the effect to run again. So in order to depict this problem, we have a simple example here. So we have a count state again, and we have a function called get results and a use effect, which is not doing nothing but incrementing the count and setting and updating the state. That is the work for the use effect. Now, for some reason, if we want like the get result function to be as a dependency array to this use effect, so what is going to happen is if I again save this code, this is going to run into an infinite loop again. The reason is simple. Every time this use effect runs, it re-renders this component, and since this get result is a function, so every time it is recreated, and again this get result has a different value as compared to the previous one, so this use effect runs again, and it in turn goes into this infinite loop. So to solve this, we can use another React hook called useCallback. Now what I'm going to do is I'm just going to completely cut this, and here I'm going to use callback from React, and then here I'm going to pass the function, the callback function, and here I'm going to pass an empty array. This means that this get result, whatever the function value is, it is never going to change. So we are passing an empty dependency array here, similar to the use effect. Now if I click on save and reload, you see it won't change because this has been calculated and memoized by React, and it is passing the memoized value of this get result function to this use effect, and that is why they are being compared and they are eventually same. That's why this use effect is not rerunning again. So now, as mentioned earlier, this is the time for tips and tricks, and I'm going to give you like a couple of tips and tricks which you can definitely use to make the understanding of the use effect more better, make your code more performant. So this is a bit confusing, but this should be brought to the account that most of us understand use effect as lifecycle methods for a functional component. Although it can be used to run different lifecycle methods which would run almost in the same time as on the class-based components, but it is not the way you should be thinking about this. Use effect is more about synchronizing your code based on something which has changed. So we discussed based on any prop or state change, if we want to do something, there we can use use effect very optimally, and in turn this will make our code more performant and clean. Now another tip which I wanted to discuss is we should use one effect for one defined task. So if our different use effect doesn't have any interdependency on the prop of state, we should definitely make a separation between them. So each use effect does a separate kind of work. Now this will help in optimizing the React re-render cycles. It won't re-render the components unnecessarily, and it will give you a modular approach to maintain more cleaner code. So this is all about the use effect, and thank you everyone for being with me till the end. If you find this content helpful, do hit the like button and also consider subscribing to this channel for more contents like this. My name is Prashun, you are watching Full Stack Simplified. We'll see you in the next video.